Konstantin, I was looking at your LinkedIn feed the other day, and I saw something come up, which really caught my attention, and it had nothing to do with bulk liquids, but everything to do with robotics. And if I'm not mistaken, you guys with Euclid, you're sponsoring a high school team who regularly takes part in a robotics competition. What's the story with that, and how did that come about?
Yeah, so we got some of our friends who started their own robotics team, high school robotics team in New Jersey, and their kids showed really promising results with the technology they were creating. So we decided that we wanted to help them out and help kids develop and see if some of those kids later on go and find interest in working with the things that we work with, so it's all about mutual interests.
They're doing some pretty amazing stuff. So there were videos on there, and the robots that they built, that was truly amazing. So they were solving tasks and doing all sorts of things on a course. And wow, it was I've never seen stuff like that in competitions like that. So to me, it was all new, and it was like, I was so surprised to see such young kids being able to build stuff like that.
And the technology stack keeps getting newer and more advanced. And so this last round, I had coached them on the use of AI, and they were using some basic elements of computer vision to detect the objects on the floor of the competition area and then move towards them and pick them up and things like that. So if you can imagine that our high school students are actually playing with that already, and they get the assignment from the robotics organization, and they look at those functional requirements and then implement those robots to actually go out there and use those technologies to complete the tasks. That's pretty amazing.
Yeah, it's just mind-blowing. So you'd think that training robots with AI is a cutting edge thing, and it's like, no, it's happening in high schools, and your kids are doing it. That's just for someone not deeply versed in technology, this is like mind-blowing. So ladies and gentlemen, what we have for you lined up today is something pretty exciting, because what we're actually going to do today is build on something that we've already discussed, specifically in episode 5, where we talked about production scheduling. And Eugene and Konstantin have been in some pretty interesting conversations over the past couple of days and weeks. And it's all related to what we've started discussing. So we agreed that our topic today would be blend scheduling, because for some reason, it's a red hot topic right now with all the clients that Euclid is working with and all the conversations they're having. So yeah, gentlemen, take it away. What are some top of the mind things that have been coming up in conversations when it comes to blend scheduling?
So there are some overlaps, obviously, between just general production scheduling of processing equipment and blend scheduling, but you still have these concerns, raw material availability and variability. You have demand forecasting accuracy, and you have quality control. So when you're talking about raw materials, you want to make sure that two of the most commonly occurring issues are somehow addressed. One of this is just availability of base oils or fruit in soft drink industry, the raw material that you're going to be making product from. You want to make sure that that's planned in advance. You plan for seasonality, and that when the production planners need it, that it's there for them to use. And that works for both processing, production scheduling, or blend scheduling. And the other one is, we always come back to storage tank capacity. So any plant has a finite amount of storage capacity. And if they are not moving product fast enough through the pipeline, or they're not planning carefully, they may overproduce and consume all of that storage capacity, and then they're stuck until they free up the capacity they can't produce anymore. And so that affects the raw material variability. And then you have demand forecasting. And that's a whole other hot topic where you usually go to sales reps to get that forecast. And your sales reps might not have their incentives aligned with what you need for production and for sourcing and trading for procurement departments. So, for example, sales reps care about meeting their quota that may be set at a high level as long as they sell some product to achieve X dollars of revenue, they may be happy. So usually the mix of how they get to their target may change between when the sales reps produce the forecast and when they actually got some results. And they would still be happy and think that everything went fine. However, if you take that information and now ask the procurement or production people how happy they are with it, of course, they're not happy because they planned to make X and instead they had to make Y. And now they have leftover materials from one product and they might be short on materials for another product. So that still happens, and it's a major contributor to variability in blending. And you have quality control, where a lot of times people in these industries, when they do blending, they have this loose approach, basically saying, hey, this is what I need you to make, but it's okay if you make it out of order or if you make it a little bit later in the day, whenever you can get to it. And there may be loose rules about how they're supposed to blend. So what you end up seeing is less of a focus on doing things right the first time, especially in blending. And that sort of invites rework. And rework, while people think, well, I'm just not going to call it rework, I'll just say I'm making an adjustment, they're adjusting all the time, now more frequently than they should have. And that results, again, in not having enough storage capacity when they need it for the things that they had planned next. They can't start what they were supposed to start doing because they're still fixing their previous batch. So it's all related, all goes together: the raw material variability, demand forecasting, and quality. And so while there is this perception that in juice manufacturing, you're inevitably going to have some adjustments towards the end of the run or the end of the batch, the best practice would be to minimize that. Yes, you can have adjustments in the end because there's variability in the chemical qualities of the ingredients, but still, if you focus on minimizing it and doing most of it right first time, you're going to move product through your pipeline much faster. And then you're going to solve a lot of the same issues.
There was a lot of stuff in there. So like each one of those 3 points could be an episode of its own. But I'm curious, Eugene, so do you come across this problem often where the salespeople are sort of incentivized the wrong way? So they end up hitting goals that are not in line with the goals of production, meaning they're quote unquote selling the wrong stuff.
Yes,
Does that happen often?
yes, it does happen often, unfortunately. And the main reason, like Konstantin mentioned, is the alignment of goals between what the salespeople are reporting, or what they are incentivized to report, versus the much more truer picture of what's going to happen. Now, nobody can read the future, as far as I know. So forecasting is inherently inaccurate, but you can make certain adjustments to make it more accurate, more in line with what's going to happen, or at least um, have the proper vector as far as the general direction it's going to go in. rather than setting high expectations for like volume and then ending up with a lot of waste because you procure too much raw material that is not going to be used due to shortcoming of the forecast. And you said it's going to be X and it's half that. What are we going to do with all the raw materials? It's really it's really a delicate balance to make sure that the forecast is accurate and the people providing you with the data are properly incentivized to provide accuracy as far as they can, as much as they can do it, rather than just high numbers trying to say, well, we're going to be growing this many percent, right? Uh, while growth is absolutely critical to any company, um, growth purely on paper is meaningless because it's not
Mhm.
going to materialize, right? You're going to report all these pretty numbers, and then in the end, you're going to be asked, okay, well, what happened? We didn't get that, right? So to get that, you need to make sure that you incentivize accuracy more than just inflation of numbers to look good. So yeah, we see that a lot, and the main thing to do about that is to look inside in the organization and see how those incentives can be rearranged so the accuracy is prioritized and not punished. Because you may be accurate, said, well, if I'm accurate, it's going to be a smaller number. Okay, good. Do that. We want to know accurate numbers rather than inflated numbers, so we end up with a whole lot of stock of raw materials that we can't use.
One thing I want to add to that is how the year plays out for the sales reps and their management. There's one very, very strong contributing factor to this, and it has to do with human psychology. And again, it goes back to the quality of leadership at the organizations. But whenever the sales reps come up with their annual budget or annual profit plan, they first usually say, I can sell this much of X, I can sell this much of product Y, and this much of product Z. And then the higher management will look at that and say, but that's not enough. We need you to sell more. And at that point, they will assign stretch targets where they say, yeah, but overall, you didn't meet our goal for this year. So we're going to give you an additional target. And that is what creates a lot of trouble for production down the line. Because depending on how they assign it and how they manage that target, it could be night or day difference for production guys. Because usually the sales reps will say, well, I'll try my best, but I don't know how I'm going to achieve it. So if the additional target is a significant proportion of the overall number that the sales rep is trying to hit, that means there's that much that they don't know where they're going to get. And so as they try to get it anywhere they can, that means greater variability, and that means that the production people will not know what raw materials they need to have on hand to actually make all this work. You see, so how that the management of goals is handled is very important. And if it's very ambiguous, that means the production side will always be looking at something like, oh, there's another 2 million pounds of product we need to make. And we didn't plan for it. And why didn't they plan for it? They didn't, because this was a stretch target. This was some things like get it anywhere you can, because the company needs to then report back to the investors that they grew from year to year. So that is one of the common issues that when that happens, usually that ambiguity is allowed to persist. But when it's there, it translates down to production very clearly. So, and creates problems there.
Who is it? And I don't know if you have a strong view on this or not, but who is it at the typical plant and I mean like which function, who has the most impact or who owns this high level planning. So where does it come together? Where's the function where all of this comes together?
That depends on the size of the organization. So you have larger and smaller organizations that deal with this. So that easily rolls up above the level of the plant manager. And then you have VP of operations, you may have the local president, whoever. So it changes between companies. The bigger the company, the more layers they have at that level who actually plans for it. So what we're saying is that there needs to be clear leadership in that space so that people know what they need to do when everybody goes outside of the normal plan of things, and now they're working on the stretch target, and the production side may not be prepared for it.
Or the other answer would be also valid in some cases, as there is no such person. There is no such alignment. You wish there was, but sometimes there isn't. And the top management may set certain goals and certain objectives for themselves, for their salespeople, for whoever at the sales part of the organization, which doesn't align at all with procurement and production side of the organization, especially when you're talking about forecast that is done at certain granularity level, such as, like, for example, monthly, right? So you can say, I need a monthly forecast for the next 12 to 18 months. It's very hard to do that if you disregard accuracy. You would say, oh, I'm just going to create some numbers, put them into the monthly buckets, and as we go, I'm just going to move them forward if I have to, or move them backwards if I have to. That creates maybe a good position for the salesperson, but a very hard target to hit for production, right? Or procurement. Because all of a sudden you are planning to do X in the next month, and they say, nah, you're not going to do that. But you already have planned for it. You already procured raw materials. You already scheduled maybe some plant capacity to deal with the volume of product that you need to make. And all of a sudden it gets shifted forward. Say, no, we're not going to do it. Why? Well, it doesn't matter. It's just, we're gonna make more of it in the next month. It's like, okay, well, so I need twice the amount of raw materials now for the next month. So that misalignment can lead to quite a few interesting issues at the production level as well, and procurement.
I see. So we have planners come to you and they say, Eucadine, we have problems. How can you help us? Because we're experiencing, raw material variability and all the other things that you've just talked about. So how do you help these organizations and these plants?
There's a few of these things that go beyond what we have with our particular services. So this is where we just talk and bring common sense to the table. So for example, when we talk about raw material variability, we say that people have to collaborate with each other internally within the company. So you have several different departments, but when we're talking about procurement or sourcing, they may be called different things. They need to collaborate with planners. And the tighter they collaborate, the better the outcome. And you'll be surprised how often we see this siloed mentality where departments may occasionally collaborate, but usually when they have a question, they don't get up and go and ask. They just assume, or they create a workaround so they don't have to ask. So collaboration and open communication across departments, it's key, and we promote that. On demand forecasting, again, we would happily talk to the senior people about the need for the leadership, strong leadership and determination, because we can clearly point out the deficiencies in the processes. And we see it a lot, that people try one way of doing forecasting, then they try another way. And then you realize that it's not about the forecasting tool. It's about the people's mindset. It's about the alignment of objectives. So that's where we have to have those honest discussions. But then we get to the quality control, to our favorite part. And this is where it's a different sort of discussion where we would emphasize the benefits of doing things right the first time. Yes, again, with blending in particular, some might say that they always need this wiggle room in the end to adjust their run or their batch because it's just the nature of how things are made with liquid manufacturing. But everybody would agree that if you focus on doing at least 95% of that batch right the first time, then you move it out the door much faster. So it's a no-brainer. And that's where we go into deeper dives and help with technological solutions, with making sure that these departments can collaborate in the tools in the systems, that everything makes sense in terms of who is doing what, and in that the quality is first and foremost, and it's built into the process. So when people have the right mindset, they treat these questions differently. So that's where we talk, and that's where we work together on some of the technological solutions.
Got it. So, what are some issues in the light of everything that we just talked about that you've seen arise at plants?
So some of the common issues we've seen at the plants are very similar to the issues we've been discussing in the production scheduling episode before. So this is downtime, increased downtime due to not having the storage capacity. So when they don't plan efficiently or when there's demand variability and somebody doesn't come to pick up your order, the storage tanks are full. And when they're full, you can't produce. So you may have downtime associated with that. Then you have increased downtime because in some facilities, these processes of planning and execution are still highly manual. They're made with Excel or paper, and there's no real-time visibility into execution. So if anything goes wrong, the execution side is delayed. And when the planners don't know that, we've seen that at some places, they may be 2 days apart. So the planners issued the instructions, the execution is 2 days behind, and the planners don't even know that. And so they continue to plan what they need to make for later, and then they realize that because part of what they planned previously wasn't even made, now they have to scrap that schedule and create a new schedule. So that's downtime just through pure lack of visibility into what's going on in real time. And then you have planners constantly readjusting the schedule, and it happens with production schedule, it happens with blend schedule in just-in-time environment. And that is because they don't have the inventory that the other facilities have when they produce to stock, and they constantly have to play around with what they have in those storage tanks. And they're adjusting all the time. And so there's a certain degree of churn in that. So those three would be the issues that we see all the time.
Okay. And what about issues that are specific to blending?
Well, blending specific issues would be things like scheduling, for example, the recipe management, blending accuracy, traceability, compliance. If we talk about scheduling, then we have to say that bill of materials, which is sometimes referred to as BOM, um, has to be something that is accurate and systematized. So it's not something that's just paper based. Uh, it has to be followed. And that would be the issue that sometimes it's not. Sometimes it's not in the system. Sometimes there are multiple variants of bill of materials, and sometimes it's just on paper. So not requiring the operators to stick to a specific order of execution prescribed by the bill of material and recipes, uh, that can lead to issues specifically in blending. Blending accuracy is another interesting topic where you really have to be sometimes very precise to achieve a certain chemical characteristics of the finished product. And if the operators don't follow those bill of material prescriptions and recipes properly, you may end up with blending errors that lead to, again, off-spec product, or that might be used in some cases with some rework, or sometimes it's just a waste product that can no longer be used, and then it's even worse. Um, Traceability and compliance, if we go to that, you have to ensure that everything that you use in the product is traceable, especially when you're dealing with food products that are for human consumption or animal consumption. You have to make sure that your processes are built in such a way that you can easily trace every ingredient that goes in. Um, in many cases, if you do not have proper tools, you may not have a good way to trace products that went into the blend. Um, Also, for compliance with specific organizations such as BRC audits and similar type of compliances in different industries, it's harder to hit certain levels of compliance if you don't have proper tools. Sometimes you may be able to pass this or pass that by some kind of stretching of data and maybe presenting the best case scenario and hoping that the audit will be, looking just at those easy cases. But sometimes that doesn't fly, and you end up failing the audit because you didn't have the proper tools or the proper knowledge how to use those tools in place during the audit.
I just want to make an analogy here with when we talk about recipe management and recipe adherence. We talked about the robotics team in the beginning of this episode, and I just remembered that there was this observation that I made that initially, when the robot is being built to achieve certain tasks, there is a plan made and everybody agrees to the plan. And then when the execution starts, very frequently the execution goes off script, and the first issue they encounter, they're already doing something else. And then they're trying to catch up to what they envisioned. And I'm talking about high school students here. One big difference between these high school students and production facilities is that these high school students, they are small in numbers. So it's a smaller team that usually works in the same physical environment. They are in the same room and they observe what's happening. But now you'll be surprised that in some production facilities, we still have these highly manual processes where the production schedule might be created in a more advanced manner by the production planner, still in Excel, not in some kind of system, but then the execution will be highly manual. And then nobody knows until the very end whether the recipe had actually been followed to the letter or whether it hadn't been followed. And so what happens then is, in the end, the quality lab will take a sample and they'll analyze it and they'll see that it doesn't meet the spec. And now the crew that worked on this has to go back and redo everything. And so the interesting part here is that in some cases, the high school students are more efficient than the production facilities. Smaller teams, yes, but we got to get better. We got to get some correct tools in the hands of the manufacturers so that they don't have to go through the same process where it's a black box production environment and they got the demand, this is what you need to produce. And then how you produce, you just do it somehow. You wing it and then hope for the best in the end. But in the end, the lab might send you back and have you redo all this. And you'll be surprised that some facilities don't even track how frequently that happens. So that kind of reinforces that behavior, because if that happens 50% of the time, but nobody's watching, there's nobody to react and panic and say, let's change things for the better. So one thing we recommend is starting to track the metrics. Go back and track how frequently you do things right the first time. And when you know, and that number shocks you, then we can talk about what you can do differently to actually assist the operators on the shop floor with tracking their execution so that they can do things right and move the product out the door with minimal rework.
Yeah, so what I loved about this episode is that we talked about the problems and the symptoms at length, and we've heard some recommendations. Now, this isn't the easiest topics. Nothing is easy in manufacturing, actually. But could you guys just give me a recap of all the recommendations that we can put in place to address these problems and issues?
If I would start off, I would say uh, first thing to do is to put some sort of automation in place for things like tank level sensors, for example. I guess that would be the easiest low hanging fruit in terms of automation. So you're not really introducing a whole lot of automated processes at this point, but you at least know with good level of accuracy what your storage looks like at any given time, instead of having to go measure anything by hand or look at the measuring tubes to see how much product you have. This way you can quickly assess what your overall inventory of all the products that you have in the tank storage really is. That creates a lot of healthy and good data that would help you move forward with more efficiency. Um, that would be number one. Number two, I would say that the real-time feedback and interoperation between planners and operators would be very important. And usually that is facilitated by a software system that is designed properly to provide such collaboration between planners and operators. If you have that, it increases your ability to avoid downtime, so that the planners are aware of what's happening at the floor level, at the production level, as it happens, instead of waiting for some results, some reports, some papers after something is done. That becomes important for planners to stay nimble so that they can adjust quickly and see what's going on at the plant level without any delay. In addition to that, on top of that, I guess the system if the system that's in place also allows the planners to model what if scenarios, that creates even more flexibility for the planners, that they're more ready to take on the challenges that may may come up during the regular manufacturing process, and say, okay, this has happened or it's going to happen. We see that. How quickly can we adjust to it? And then if you have the tool that allows you to implement different what if scenarios, like what if I do this, what if I do that, um, and it allows you to do it quickly and easily, and then implement those changes into the actual schedule, that is a big win. So if you have something like that, that's definitely going to help you avoid, again, downtime, avoid waste, and allow you to sidestep the bottlenecks that may be created by uh, n- you know missing communications when you don't have these systems in place.
Awesome. Anything to add to that, Konstantin?
Yes, I'd say one thing that just hit me, and we keep coming back to this topic, is the management should really focus on hiring leaders, hiring change management agents, because there are these additional things that anybody dealing with blending issues would benefit from. But you need to have people on site that are not afraid to try new things. And sometimes they would be the ones doing some hand holding with the other users that are less courageous. So, one thing we talk about is automation and MES systems. So, implement manufacturing execution systems to help automate the processes and see in real time what's going on. Then you have advanced quality control systems. You want to make sure that you focus on quality and you see real-time changes in quality. So that's important, not just at the very end of the process. And then you have training and development. There's never enough. And of course, in our particular company, we've come up with a nice way to utilize artificial intelligence to actually help train the operators faster. So it's not dumbing them down, but it's actually making them more productive by assisting them right there on the spot. So investing into training is very important. And when you have people trained and you're investing in employee development, they'll think differently. So then they're going to actually be interested in the things I'm going to say next, like process standardization. When you have standard processes across your facilities, you can benefit by using economies of scale. Then you have integrated systems. When you have integrated systems, you cut out a lot of waste. One example of this is when you have production planners create their schedule, it flows through the system to the execution side. On the execution side, people use the system to go by recipe steps, execute everything, and then at some point the system says, oh, now it's time for you to go and take a quality sample. And by the way, you don't need to do that manually. Here's a barcoded label, and the system prints it for you. You take the label, you put it on the sample, and on the container. You take your sample, take it to the lab. When the lab gets it, they scan it in. That's it. That's all they do. They don't need to figure out what we see in a lot of cases where there are these jars with manual writing with a Sharpie on it. And of course, different people's handwriting differs. So then the lab technician is to figure out what they wrote, and then they create all these samples. So none of that is needed when systems are integrated. It all goes out the window. It's all waste. You just get your jar, you scan it in, and you start analyzing the stuff that you need to analyze. You do your testing. So then when you're done as a quality technician, you push the button, say, I'm done. This sample is either rejected or approved. And then you don't need to further communicate anything to anybody, because the integrated systems will actually communicate back to the operators and let them know that their sample has been rejected or it has been approved. And by the way, here are the results. Here are the chemical tests they ran. So integrated systems help to reduce waste. A lot of wasted activities, a lot of wasted time will be thrown out the window, and you can then focus on things that are more important. And then, of course, the last one, continuous improvement. I'd always recommend everybody to focus on continuous improvement. That's the mindset we've been advocating since the beginning of this podcast, that it all starts up here. If you focus on making things better every day, then it will all come together in the end. You just have to be honest with yourself, see results for what they are, and look for improvement.
When are we going to do an episode on AI? That's one of the things that came to mind as you were talking about this. I can't believe we haven't done an episode on how manufacturing uses AI. We've got to get there soon.
Yeah, maybe we'll do the next one on AI, because there is stuff happening, and there is some interesting information that is ready to be shared.
Great, great. I'm so looking forward to that episode. And also perhaps a future episode when you're going to bring one of the robots your sons built. have the robot appear on the efficiency equation and have the robot teach us something about manufacturing.
You know what? I got to tell you, though, one thing that robot taught me that I did not expect, it was totally unexpected for me, because we talked about, computer vision and all these different things with the students. But there are some things that students think of that adults don't think of. And one of them with that particular robot was how it is controlled. So all of them get this kind of controller, like a game controller, looks like an Xbox controller, pretty much. And you have these little joysticks, and you can push them and operate the robot. However, what the robot does in response to what you do blew me away, because with that particular robot, you didn't have to think where the face of the robot is relative to where it's going to go. So that was very important. When that was explained to me by a high school student, he said, look, this is implemented differently from anything conventional that you've seen out there. And I was immediately thinking, remote controlled race cars. You have to know where it's looking to understand where it's going to go. In this case, you didn't have to. He said, the reference of the coordinate system is over here. You stand here, and now you control it. And when the robot spins, and it's in any orientation, when you push forward, it's still going to go forward relative to where you are looking, not relative to where the robot is oriented. When I tried that in my own house, it was so easy to control that thing. It no longer mattered. It's like, it doesn't matter where this thing is facing. It's just so easy because I can see it moving away from me. And he said, basically, this is made to make it easy for the students to control it. So it's how you stand over here, where you look as a person, not where the robot is looking. And they just inverted that control system. And it just blew me away that, why haven't adults thought of that so many years ago? So many of these widgets that we control, they kind of go where they're looking, and you can go left or right, forward and back. And this was left and right, forward and back, relative to where you are standing as a person and looking, and made such a big difference. And I was blown away. Again, one day we're just going to have to hire some of these bright students.
Yeah, I was going to say, when are you going to put those high school kids in manufacturing plants? Because they would probably put a few things around and make things better. All right, ladies and gentlemen, that was it for episode 9 of the Efficiency Equation podcast. We're so glad that you were with us again. And we're looking forward to episode number 10, double digits. And so we're looking forward to that episode. As Konstantin said, it's highly likely that it's going to be about AI in controlling manufacturing execution and training people. So stay tuned for that. And we are out.
Thank you, Dan.
Thank you.